Example 3, find the vertical stretch or shrink, which is the amplitude.
Sorry, I'll own up. That's my whoops. We're finding amplitude here.
Okay, so the amplitude, if we remember back from the previous slide, is the number that's in front of sine or cosine.
Right in front of sine or cosine.
Okay, so what is the number right in front of cosine?
Well, how many cosines are there?
I have one cosine.
That's what I see, so that means there's a 1 in front.
So there's not a vertical stretch or shrink.
There's not, but the amplitude is 1. So I guess you could say it's being stretched by 1, but I don't know.
Or shrunk by 1.
Or shrunk by 1.
We should just say the amplitude.
No, it's an amplitude 1. Yeah, it's good safe.
Okay, B, what's the number in front of the cosine?
Okay, that's a half. So amplitude in this case would be a half. Now this would technically be a shrink because our normal parent graph goes all the way up to 1. So if we don't go all the way up to where we originally start, we're going to have some shrinkage.
Right, so vertical shrink of 1/2.
1/2 a Ruskies.
All right, now this is kind of hard to read on here at least. That says -3.
-3 cos x.
Now, when we do this,
cos x.
The number in
Grandma
front,
fell and broke her cos x.
The number in front of cosine, we take the absolute value of whatever that is.
Right.
So this is a +3. It doesn't shrink, stretch. It doesn't stretch by a -3.
Stretches by 3, and
Go ahead.
This is an instance where amplitude is always positive.
Right.
Always.
Because it goes up and down 3. We're talking about a distance here. How high does it go? How low does it go?
Right.
Like amplitude is 3. Never mind. Vertical stretch of 3.
Right. Now, the negative in front means it reflects over the x-axis.
Right. It reflects over the x-axis.
I'm just taking in, making me think about Christmas break.
Okay.
Yeah.
Enjoy it.
Now, these two things on example 4, find the horizontal stretch or shrink in period. Those actually are kind of
No, that's going to happen. And so, again, we've got our parent function to start with, so there really is nothing going on in that.
Right, there's no horizontal.
Right, he's just normal as one can be.
When talking about trig. Okay, but the period of this is 2 pi over the number in front of x, which is 1.
Right.
So 2 pi over 1.
Which is 2 pi.
So the period is 2 pi. Because again, that's our parent graph. That's what's normally going on. Now on this one, -2 sine of x over 3. Well, we've got a 1/3 in front of x. And so when we talk about horizontal stretches and shrinks, if this is a fraction, that means we're stretching.
Right, it's the reciprocal.
Yeah. So this is a horizontal stretch
by 3.
By 3. Okay, the period is 2 pi over 1/3.
Right, which now rewind back to like 5th grade or whatever. When you divide by a fraction, you have to multiply by its reciprocal.
So this is 6 pi.
So it's going to take 6 pi units to completely go through one whole
shebang,
rinse and repeat sort of thing.
The period of it's 6 pi. And so if you need to look at the period first and figure that computation out, 6 pi, doesn't it make sense that it horizontally stretches because 6 pi is longer than 2 pi?
Right.
So
what do you think, Mr. Boulware?
Yes, horizontally stretch.
Yeah, totally. Okay, so
or vertically shrink.
So okay, so now y equals 3 sine of -2x.
Wow.
So that negative inside
doesn't matter for shrink or stretch. It only means that now we're going to reflect over the y-axis.
Right. This is making our x negative, which means we are reflecting across the y-axis.
Right.
Okay, but it didn't really ask us about that. We're just pointing it out. What it did ask us, though, is
horizontal shrink or stretch.
So since we've got a 2 here, that means that we're shrinking by a factor of 1/2.
Right.
Horizontally.
Right, because it's the reciprocal of when the number is outside of the function.
Horizontal shrink of 1/2. And then our period is 2 pi over 2.
Over 2, not -2, but just 2.
Which is pi. So the period of the function is pi
And that tells us then how far we have to go before everything starts to repeat.
Right.
Not just one specific value, but all the values, the
One
pattern
hill,
of values.
one valley has to happen by the time that we get to pi.
Right.
So,
So you can tell then, accordion in.
yep, it's going in.